Oh, hi there. Thanks for showing up for your learning. It's Tutor Grant, and we're going to take a look at using factor trees to get past some of the challenging factorization on the cross numbers. So this is a technique that you actually this is one of like your top math techniques to build your number skills is just get really good at factorizing numbers. So here's how it works. I'm going to try this one. 7887. Oh my goodness. This looks hard. So here's what I do. I write the number down somewhere where I've got some scrap paper to work, 7887, okay? And I'm going to first test divisibility by the different primes. So 2, 3, 5, 7, 11, and so on, okay? But generally, this is going to be enough. I mean, for most of the questions you're going to need to do, 13 is kind of hard to apply. And there is a test for 7, but I'm going to tell you I never use that test. I don't like it. So let's talk about them. Is this number over here, 7887, divisible by 2? No. Okay, you know this because you can test it very easily. Is the number even? You only need to look at the last digit. Okay, a 7 is not divisible by 2. So now we test 3. Our divisibility test for 3 is you take the digit sum of that number. So I add all the digits together. 7 plus 8 plus 8 plus 7 happens to equal 30. 30 is divisible by 3, so this one is definitely divisible by 3. So I'm going to take that factor out, and then I divide it. Okay, so I actually would recommend doing this long division algorithm on the side, or if you can do it in your head, that's amazing. And if you're using a calculator for your cross numbers, it's probably fine. Okay, so 3 goes into 7 twice, leaves 1 remainder, goes into 18 6 times, 0 remainder, goes into 8 twice. That's a very strange way to write 2. Oh, 6, 2, leaves 2 remainder, so 3 goes into 27 9 times, 2 6 2 9. Now I can test, is that number divisible by 3? 2 plus 6 is 8, plus 2 is 10, plus 9 is 19. No, it is no longer divisible by 3. I have removed all the factors 3 from this number. So now I need to check for 5. Is this number divisible by 5? No, it's not divisible by 5. Just like 2, you just check the last digit. If it's a 0 or a 5, the number is divisible by 5. This one is not. Checking for divisibility by 7, there's a fancy trick that I can never remember and I don't care to. The reason I don't care to is because I got enough stuff up here without worrying about it. Okay? I mean, like, there's other ways to do it. Okay? So I take 2, 6, 2, 9, and I subtract something that I know to be close that I'm sure is divisible by 7. That's going to leave me 529. All right? And then I'm going to subtract something that I know to be divisible by 7 as well. So that's going to give me 29 minus 39, right? 39 would be left there. 39 is not divisible by 7, so this number is not divisible by 7. My test, if you notice, is I just subtract things that I know to be, I do that subtraction, and then I just subtract another piece that I know to be divisible by 7 until I get to a small enough piece where I can tell you 39 is not divisible by 7. So this number is not. 11 has a super cool test. I'm so excited we got here. This is the way you apply your test for 11. Just like the digit sum for 3, except with 11, you do what's called the alternating digit sum. We add 2, we subtract 6. We add 2, we subtract 9. Pardon me. This works out to negative 11. So you add, subtract, add, subtract, add, subtract alternate digits. That tells us this number is absolutely divisible by 11 when the result is itself divisible by 11. Okay, negative 11 is divisible by 11. It will give you negative 1. So, hooray. 0 also passes the test, like 121, right? Or 77. These numbers are divisible by 7. Add, subtract gives you 0. Add, subtract, add gives you 0. 0 divided by 11 is absolutely 0. So that is divisible by 11. This one gave us negative 11. So hey, cool. Here we go. So now we do our long division again. out on the side to keep your work tidy. Tidy. Okay, 2, 6, 2, 9. So 11 goes into 26 twice, leaves 4 remainder, goes into 42 3 times, leaves 9 remainder. 11 goes into 99 9 times, 239. So this leaves us 11 and 239. And then, here's the hint. We're looking for a 3-digit number. We've already tested all the primes up to 11. This number is no longer divisible by 11. If I divided that number by a 2-digit number, it would become 2 digits. So that's our clue that 239 is prime. I don't happen to have my primes memorized that high, but I certainly have them memorized up to 100. And you will too if you do a lot of cross numbers. Okay. That being said, I don't know divisibility tests for all my primes. I just have to long divide and see if it works if I'm testing for 23 or something. If I wanted to up level my skills, I'd learn the special tests for 23, 29, 37 has a special test. I don't know them. I just divide. So I go ahead, and that was 2 down, and it's 239. So we proudly put in 239 here and keep going. I want to do one more here. 7997, not divisible by 3, not divisible by 5, not divisible by 2, not divisible by 7, because I can subtract 7777 from it, and that leaves me 220. 210 is divisible by 7, so 220 certainly isn't. But it is divisible by 11, so this one would start 7997. I would divide out my 11. Why? Because plus minus gives me 0. Okay, cool. So anyway, do that and enjoy your cross numbers. And I hope that helps about how to do a factor tree. So my factor tree, my final product is, I know that I can write out 7887 is equal to 3 times 11 times 239. And that's the only way to express this number as a product of primes. Thanks very much, everyone, for showing up for your learning. It was great to get this question.